Have you ever wondered why the Earth shakes? Well, if you have, then you're in the right place because today we're going to delve into the fascinating world of earthquakes. An earthquake is a natural phenomenon that sends shivers down our spine, and quite literally the earth beneath our feet. It's like the Earth's way of releasing pent-up stress, much like how we might sigh or groan after a long, tiring day. But where does this stress come from? In order to understand this, we need to journey to the Earth's crust. Our planet's outer shell is not a single solid piece, but rather it's made up of several large slabs called tectonic plates. These plates are constantly on the move, albeit very slowly, sliding past each other, colliding or pulling apart. Now imagine trying to slide two rough, jagged pieces of rock past each other. They wouldn't exactly glide smoothly, right? Instead, they'd get stuck, causing stress to build up in the surrounding rocks. This is exactly what happens when tectonic plates try to move past each other. The stress builds and builds until finally it becomes too much and the rocks break or shift, releasing the stored energy in the form of seismic waves. These waves are what we feel as an earthquake. Earthquakes can happen anywhere on Earth, but they're most common along the boundaries where tectonic plates meet. Some parts of the world, like California or Japan, are notorious for their seismic activity because they're located right along these plate boundaries. But remember, an earthquake is not something to fear. It's a natural part of our planet's dynamic geology, a testament to the living, breathing entity that is Earth. It's a reminder that our planet is constantly changing, evolving, and reshaping itself just like we do. So the next time you feel the ground beneath you move, remember it's just the Earth's crust adjusting itself. But what exactly is happening deep beneath our feet when an earthquake occurs? Well, to answer that question, let's first journey to the very core of our planet. The Earth's outer layer, or the crust, isn't just a single unbroken shell. It's actually made up of several large pieces like a 3D jigsaw puzzle known as tectonic plates. These plates aren't stationary. They're constantly moving, albeit at a snail's pace, gliding over the semi-fluid layer beneath known as the asthenosphere. Now, the edges where these tectonic plates meet are called plate boundaries. There are three main types of these boundaries: convergent, where plates collide; divergent, where they pull apart; and transform, where they slide past each other. It's at these boundaries where the magic, or rather the shaking, happens. Imagine two plates at a transform boundary, like the infamous San Andreas Fault in California. They're trying to slide past each other, but they get stuck due to the roughness of the rocks. The stress builds up over time, and when it becomes too much, the rocks break, releasing a tremendous amount of energy. This sudden release of energy is what we call an earthquake. But how does this energy cause the ground to shake hundreds of miles away? This is where seismic waves come into play. These waves are essentially the energy from the earthquake spreading out from the epicenter, or the point on the Earth's surface directly above where the earthquake occurred. There are two main types of seismic waves: body waves, which travel through the Earth's interior, and surface waves, which travel along the Earth's surface. It's the surface waves that cause the most damage, as they're responsible for the shaking we feel during an earthquake. So, when you feel that sudden jolt beneath your feet, remember it's the result of massive tectonic plates moving and releasing energy in the form of seismic waves. This is an incredible testament to the dynamic nature of our planet. In a nutshell, earthquakes are the result of our ever-moving Earth. You might be thinking, how do we know all of this? Great question. We have some pretty nifty tools to help us measure earthquakes, and that's what we'll be exploring today. Let's start with seismographs. These are essentially the detectives of the earthquake world. They're tasked with the job of tracking down and recording the evidence of seismic waves, the energy that earthquakes emit. These waves travel through the Earth, causing it to shake. When they pass by a seismograph, they cause a suspended mass to move, and this movement is recorded. The resulting graph, or seismogram, shows the varying intensity of the shaking over time. The seismogram is a bit like a diary of the earthquake's life, recording each tremor and shake. It provides us with invaluable data on the time, location, and strength of the earthquake. But how do we quantify an earthquake's strength? Enter the Richter scale. Developed in the early 20th century by Charles F. Richter, this scale assigns a single number to quantify the energy that an earthquake releases. The scale is logarithmic, meaning each whole number increase on the scale represents a 10-fold increase in measured amplitude and roughly 31 times more energy release. For example, a 6 on the Richter scale releases 31 times more energy than a 5. It's important to note that the Richter scale isn't perfect. It's less accurate when measuring very large or distant earthquakes. So scientists sometimes use other scales like the moment magnitude scale, which provides a more accurate measure for these types of quakes. Nonetheless, the Richter scale remains a widely recognized tool for quantifying the magnitude of most earthquakes. It gives us a way to compare earthquakes and understand the potential damage they can cause. Thanks to these tools, we can understand and measure the power of an earthquake. With continuous advancements in technology and our understanding of seismic activity, we're better equipped than ever to study these fascinating and formidable forces of nature. Before we continue, if you're finding this video interesting, consider subscribing to our channel. It's a seismic wave of support for us. Don't miss out on our upcoming content as we continue to delve into the mysteries of our planet. And if you have any questions, drop it in the comments below. We're here to dig up the answers. Stay tuned for more fascinating insights into our dynamic Earth. But what does all this scientific jargon mean for us, the people living on the Earth's surface? Well, in the simplest terms, the shaking of the Earth has far-reaching implications that extend beyond the realm of seismology, directly affecting our societies in profound ways. Earthquakes, you see, don't discriminate. From towering skyscrapers to humble cottages, all structures are at risk when the ground starts to shake. In a matter of seconds, an earthquake can reduce a bustling city to rubble, causing immense damage to buildings and infrastructure. The loss is not just physical. The toll on human lives can be devastating, as seen in numerous seismic events throughout history. This destruction also brings with it an economic impact. The cost of rebuilding, the loss of productivity, the disruption of trade, these ripple effects can cripple economies, both locally and on a global scale. In the aftermath of a significant quake, societies can spend decades recovering and rebuilding. But it's not all doom and gloom. This knowledge of earthquakes and their potential devastation underscores the importance of preparedness. By understanding the science behind these natural phenomena, we can design and construct buildings that are better equipped to withstand seismic events. This is where earthquake engineering comes in, a specialized field dedicated to creating structures that can flex and sway with the Earth's movement rather than crumbling under it. Moreover, being prepared goes beyond just building codes. It involves developing effective emergency response plans, educating the public about what to do when an earthquake strikes, and investing in early warning systems that can provide precious seconds for people to seek safety. In a world where we can't prevent the Earth from shaking, these are our best defenses. We can't always predict when or where the next big quake will hit, but we can control how we prepare for it and how we build our communities. By doing so, we can minimize the impact of these inevitable seismic events. While we can't prevent earthquakes, we can prepare for them and build our communities in a way that minimizes their impact. So, there you have it. A deep dive into the fascinating world of earthquakes. We've journeyed through the rocky layers of our planet, exploring the movement of tectonic plates that cause the Earth to shake. Like giant puzzle pieces, these plates shift and collide, building up tension that eventually gets released in the form of seismic waves. We've learned about the science behind these natural phenomena, from the initial tremors of a foreshock to the powerful pulsations of a main shock. We've discovered how scientists measure earthquakes using ingenious instruments like seismographs and seismometers to track and quantify the energy released. But we didn't stop at the science. We also delved into the profound impact earthquakes can have on society. We've seen how these seismic events can trigger tsunamis, landslides, and other disasters, reminding us of the immense power of nature. Yet we've also witnessed the resilience of communities, their ability to rebuild and recover in the face of adversity. As we wrap up, let's remember that understanding earthquakes is not just about science. It's about fostering a sense of respect and awe for the dynamic forces that shape our planet. It's about being prepared, staying informed, and learning how to protect ourselves and our communities. Remember, every shake, every rumble is just a reminder of our planet's dynamic nature. Until next time, stay curious and keep exploring.